Hello students, this is Prathamesh Tupare, your physics sir, and today we are going to learn next part, that is Coulomb's law of electric force, which is very important law of electrostatics. Okay, so before learning the Coulomb's law, let me revise the previous class. In the previous class, we discussed different methods of charging, that is charging by friction, that is charging by contact, and charging by induction. Correct. Next we saw something called as a point charge, which we are going to use today. Okay, so now moving on with the next topic, that is Coulomb's law of electric force. So let us look at the statement of the Coulomb's law. The Coulomb's law states that the force of attraction or repulsion between two stationary point charges is. Now one thing you have to remember is, the first thing is, the charges which you consider should be stationary, they shouldn't be moving. Okay, we are dealing with electrostatics, that is basically our charges are not in motion, they are stationary, they are at rest. So the first thing is our charges are at rest, and the second thing is there are point charges. We discussed what is point charge in the last class. A point charge is the one whose dimension are very tiny, very small as compared to the distance between the two objects or the two charges, or the distance between the charge and the observation point. Okay, that is a point charge. So the force of attraction or repulsion between the two stationary point charges is first directly proportional to the product of magnitudes of the two charges and inversely proportional to the square of distance between them. So let us learn this in parts. Okay, one by one we'll see. Okay, so the first point is saying is, we have 2 point charges. So let me draw 2 point charges, Q1 and Q2. Okay, let us say that these 2 point charges are positive point charges. Okay, both are positive. This is also positive, this is also positive. So the force between them is obviously going to be a repulsive force, because both are like charges, they are of the same kind, they are of the same nature. Okay, let us say that the distance of separation between them is r. Okay, r is the distance of separation between these 2 point charges. Okay, so in this case, this force of repulsion between them, the force of repulsion, now it is as good as this is one magnet, this is another magnet. You try to get the north poles closer to each other and they will try to repel each other. This one will move away, this one will move away. In short, this one will push this away and this one will push this away. Okay, so that is the force of repulsion between them. So this force of repulsion between them, let us say F. First point is what? Is directly proportional to the product of their magnitudes. Okay, so it is directly proportional to the product of magnitude. That is, product meaning what? Multiplication. What is the magnitude of the first charge we have taken? Q1. What is the magnitude of the second charge we have taken? Q2. So Q1 multiplied by Q2. So the force of repulsion is directly proportional to the product of the magnitudes of the two charges. And secondly, the force is inversely proportional. Now what is inversely proportional? It is 1 upon. This is directly proportional, directly in the numerator. Inversely proportional is 1 upon whatever quantity is, it will come in the denominator. So now force is inversely proportional to the square of distance between them. Now what is the distance between them we have considered? Is r, but it is square of the distance between them. So r square. So let us combine this together. So F is proportional to Q1 and Q2. Q1 multiplied by Q2. So I'll write it as Q1 and Q2. And it is inversely proportional to R square. So this is the final statement you get. Now let us turn it into a formula. In the formula we always have a equal to sign. We never see a proportionality sign. So let us remove this proportionality sign and we'll put a equal to sign. So what will happen? F is equal to, when we remove a proportionality sign, we have to add a constant. So let us add a constant K. Okay, so K times, then this quantity will come, that is Q1 Q2 upon R square. Okay, so this is your statement, that is the Coulomb's law statement. F is equal to K, that is proportionality constant, times Q1 Q2 upon R square. Now this K is called as the constant of proportionality, and in this case it is specifically called as the electrostatic force constant. So K is called as the electrostatic force constant. Okay, so it is called as the electrostatic force constant. The value of K depends upon various factors. Some of the factor is nature of the medium between charges. So what do I mean by nature of the medium between the two charges? These are my two charges. This can be placed in water. This can be placed in any kind of metal, a conductor, correct? Charges may be present in conductor. Okay, charges may be present in vacuum. Charges may be present in air, that is air, correct? So it depends upon the nature of the medium. It can be air, it can be water, it can be metal, it can be conductor, any kind of conductor. Okay, so nature of that conductor, nature of the water, nature of the air, vacuum. Okay, so it depends upon that medium which is present in between them. And secondly, it depends upon the SI unit, or rather in general we'll say it depends upon the unit, type of unit in which we define or we measure F, Q1, Q2 and R. So it depends upon the units we use for force, the two charges and the distance between them, the system of units which we use. Okay, so on these two factors this value of K will depend. Moving on. Now if these two charges Q1 and Q2 are placed in vacuum and all the factors, that is all the quantities, are taken in SI units, then the value of K is given by 1 upon 4 pi epsilon naught. Note this, okay? This symbol is called as the epsilon naught. 0 is called as the naught, okay? So value of K when first condition is what? The two charges are placed in vacuum. The second condition, when all these quantities, that is F, Q1, Q2, R, are taken in SI units. That time the value of K is given by 1 upon 4 pi epsilon naught, whose numerical value is 9 into 10 raised to 9. And the unit will be Newton meter square per Coulomb square, which can also be written as Newton meter square. If I take this Coulomb square on top, this will become per Coulomb square, that is minus 2. So since it is coming on top, it will become minus 2. Okay, so this is the value of K, where epsilon naught here, this epsilon naught is another constant which is called as the permittivity of free space. Okay, you need to remember these terms. Okay, this is called as the permittivity of free space, and its value is given as, you need not remember this value, it is given as 8.854 multiplied by 10 raised to minus 12. Units are Coulomb square, Newton inverse, meter square inverse. Okay, so this is the value of the permittivity of free space you need to know. So from board point of view, you need not remember this, but from your entrance point of view, this is very important. Okay, yes. So now finally, how can we write the force expression? The force of repulsion or the force of attraction between the two charges in free space or in vacuum is given by 1 upon 4 pi epsilon naught. What I have done is I have just replaced this value of K by 1 upon 4 pi epsilon naught. So 1 upon 4 pi epsilon naught, the resting remains same, Q1 Q2 upon R square. That is the square of distance between the two charges. Okay, so now using this statement, next we are going to define the 1 Coulomb. Okay, we are going to define what is 1 Coulomb. Okay, so now to give the definition of 1 Coulomb, I am going to do one thing. I am going to set my charges to 1 Coulomb. Okay, the value of charges to 1 Coulomb. So let us say that Q1 is equal to Q2 is equal to 1 Coulomb. The two charges are having a magnitude of 1 Coulomb. Let's say both are positive. So since both are positive, definitely there will be force of repulsion between the two. So let us say this charge is trying to push this away, and this charge is trying to push this one away. So the force is repulsive force. They are going away from each other. Let us say that the distance between them is 1 meter. So I'm setting my R as 1 meter. Okay. So now let us substitute the values in this formula. So F will be equal to What is the value of 1 upon 4 pi epsilon naught? We just now saw it is 9 into 10 raised to 9. So let's put it over here. 9 into 10 raised to 9. We have considered our first charge as 1 coulomb. Second charge is also 1 coulomb. So it is 1 multiplied by 1 divided by the distance between them I have taken as 1 meter. So 1 square. So 1 multiplied by 1 divided by 1 square is again 1. So this will come to 9 into 10 raised to 9. What is the SI unit of force? SI unit of force is newtons. Okay. So how do we define 1 coulomb now? We will define 1 coulomb as it is that amount of charge which we have considered. It is that amount of charge that repels an equal and similar charge. Okay. So now we have considered equal charge. See, 1 coulomb, both are equal, and similar. Similar meaning what? If this is positive, this is positive. So it is that amount of charge which will repel. Since it is equal and similar, it will repel. Correct? Repel the other charge. So it is that amount of charge which will repel the equal and similar charge with how much force? With the force of 9 into 10 raised to 9 Newton when it is placed in vacuum, when this is placed in vacuum at a distance of 1 meter between the two charges, when it is when they are 1 meter apart. So this is your definition of 1 coulomb. Okay, so I'll just read the statement for you from the notes. So 1 coulomb is that amount of charge that repels equal and similar charge with a force of 9 into 10 raised to 9 Newton when placed in vacuum at a distance of 1 meter from it. Okay, now it is very much similar. I've just cut it down in different sections and explained you. Okay, so that it becomes easier for you. So this is your Coulomb's law of electric force. In the next class, we are going to study the Coulomb's law in the vector form. Okay, so this we have just written in terms of magnitude. Everything we have seen in terms of magnitude. Next, we are going to include the direction also, and we are going to define our Coulomb's law again. Okay, so this is it for today. I'll see you in the next class.